Alright viewers, welcome back to my YouTube channel. Well, in today's video, as we can see on the board, we have 4 resistors that are connected in series parallel. We have resistor 1, resistor 2, resistor 3. So this becomes resistor 3 that are connected in parallel. And we have resistor 4 that is connected in series with a parallel circuit. We are not given the total current, and voltage is given. The total voltage is given. Right. The question says that find A, total resistance, B, voltage drop, current in each resistor. So first of all, if a question is given to you in this manner, what you have to do is that you find the resistor that is in parallel, the equivalent resistor in parallel. So here we say 1 over R. Let's use the P representing the parallel. Is equal to, so we have 1 over R1 plus 1 over R2 plus 1 over R3. So let's put the values there. 1 over R1 is 12, 1 over 12, plus 1 over R2 is 1 over 18, plus 1 over R3 is 1 R3 is 1 over 3. So here 1 over RP. Let's divide this 3 and see what we have. So we have 1 divided by 12, 1 divided by 12, we have 0.083, we have 0.083, then 1 divided by 18, 1 divided by 18, we have 0.055, 0.055, and then 1 divided by 3, we have 0.333, 0.333. So 1 over RP. Now let's add these 3 and see what we have. We have 0.083 plus 0.055 plus 0.333. And then we have our answer as 0.471. So 0.47. Alright, so when you get this answer, because we are looking for the R equivalent in parallel, the R parallel, we say RP. What happens is, if the RP stands alone, then we say RP is equal to 1 over what? 0.47. So our RP now become 1 divided by 0.47. 1 divided by 0.47, we have our answer as 2.13. 2.13 ohms. Alright, so this becomes our R parallel as we added in, or we use this formula to check. This is the answer we have for the parallel. So now we are asked to find A. And you know, now this one it becomes what? In series with this. So what you will say is that total resistance is equal to RP plus R4, which is equal to, RP is what? 2.13 plus R4 is 25. So you add it and you have your total resistance as 27.13 ohms. So this becomes your total resistance. Now that we have our total resistance, let's look for the voltage drop. But before then, we don't have the total current. So we say total current. We know total current is what? Total voltage over total resistance. Our total voltage is 220. Our total resistance is 27.13. So our total current is equal to, let's see what we have, 220 divided by 27.13. 0.13. We have the answer as 220 divided by 27.13. We have our answer as 8.11, sorry, 8.11 amps. So this becomes our total current. Now in series circuit, the same amount of current flow in series circuit. So what we say here is that we say voltage. Now they are asked us to find the voltage drop. So B, because the same amount of current flow in 25, so the voltage, we know formula for finding voltage is equal to current times what? R. So what you only do is that this is the voltage drop in R4. So current, that is the R total. So the R4, so the voltage drop in R4. R4 is what? So R4. So voltage drop in R4 is equal to total current 8.11 times R4, which is 25. So voltage drop in R4 becomes, let's see what we have, 8.11 times 25. We have our answer as 202.75. 202.75 volts. So this becomes the total voltage flowing, or the voltage drop flowing in R4. So let's see the voltage drop. So BII is voltage drop in parallel circuit. So let's put the P to represent the parallel circuit. It's equal to, this time in parallel circuit, because we have this, we subtract the voltage drop in R4 minus the total voltage. Then we have the voltage drop in parallel. So we say voltage drop in parallel is equal to total voltage minus the voltage drop in R4. So voltage drop in parallel, we say total voltage is 220 minus voltage drop in R4, we say 202.75. So voltage drop in parallel, let's see what we have here. So 220 minus 202.75, we have our answer as 17.25 volts. So this is the voltage drop that we have in R4 and voltage drop that we have in the parallel. Now that we have the voltage drop in parallel, so these three resistors have a voltage drop as what? 17.25 volts. And then the voltage drop in R4, which is 202.75 volts. All right. So now that we have the voltage drop in the parallel, we use the voltage drop now to check each of the resistors, and then we'll have the current in each of the resistor. And we know, so we say C. So we say current in resistor 4, which is the series circuit, is equal to what? Total current. So we say current in R4 is the same as what? Where is it? 8.11 amps. So this is the current flowing in R4. So let's find I. So this become our I. So I current in R1. This time you use the voltage drop in the parallel circuit. So we say voltage drop in the parallel circuit, voltage drop in the parallel circuit, parallel over R1, which is voltage drop 17.25 over R1 is 12. So current in R1 is equal to, so let's check, 17.25 divided by 12. We have our answer as 1.44. So 1.44 amps. So this becomes our current in R1. So II, current in R2, which is voltage drop in para. You keep on using the same voltage because we are looking for the current in para. So you keep on using the voltage drop in para to divide each of the resistors in para. So voltage drop in para over R2, which is voltage drop is 17.25 point, the R2 is 18. So current in R2 is equal to 17.25 divided by 18. And then we have 0.96 amps. So this becomes the current in R2. So I current in R3, we say voltage drop in para over R3. Voltage drop in para is 17.25 over the R3 is 3. So current in R3, so 17.25 divided by 3 will give us 5.75. So 5.75 amps. So this becomes the answer. If you are given a question in this way, this is the way we go about it. So when you add the current that flows in R1, current that flows in R2, current that flows in R3, let's do it and see what we have. You have the same as the total current, which is the same amount of current that flow in R4. So we say 1.44 plus 0.96 plus 5.75, and we have our answer as 8.15, which is almost the same as the total current. So this is the answer for when a question or a circuit is given, and for you to calculate for questions like this. This is the way we go about it. Thank you so much. My name is David Tetekwote. Go on YouTube, write David Tetekwote into bracket, calculation and practice, and you see more of my video. But for now, this is the answer for this tutorial. Thank you so much. Like, comment, share my video. Bye bye.